MSTP, also known as Master Slave Token Protocol, as many of you know, can support up to 128 master devices. Based on lots of friends in the industry, we hear the recommendation to be somewhere around 25 to 30. It's a good balance between the number of devices you can connect without using so much of the bandwidth that pushes you towards a problematic system. Well, first of all, the system does become quite large to diagnose and troubleshoot. But second, also, naturally, when you have a lot of devices, the network does tend to physically be longer, tend to have to drop the baud rate so that the zeros and ones still have clean waveforms. So the zeros are clear zeros and the ones are clear ones. So the compromise of going very large network, but then dropping the performance, it just doesn't work out very well. Do you really want to get into a case where you're calculating how much bandwidth you have and therefore deciding if you can go to 50, go to 60? In general, 25 to 30, based on lots of friends in the industry, we hear that that's a good compromise, a good fit. MSTP and BACnet IP is very different. MSTP does allow you to daisy chain devices using a single physical medium, a single wire basically, and connect lots and lots of devices. It reduces the cost of deploying a physical network in MSTP. Whereas in BACnet IP, even if it's multiple Ethernet cables, there's still distinct links. Difference number two, MSTP is what we call half duplex. And BACnet IP, unless we're talking about very, very, very old hubs, we're talking about full duplex. What does that mean? Half duplex means that when one device communicates or talks on the network, no other device can talk. Whereas in BACnet IP, multiple devices can talk at exactly the same time, and they can receive and transmit at the exact same time. Simply by going from a half duplex to full duplex, you double the throughput on a BACnet IP network. Now, difference number three. As you all know, BACnet IP, we're talking about at the minimum 10 megabits per second, whereas in MSTP, we're talking about 38,000 bauds, 38,000 bits, 78,000 bits. If you do the math, it's not even close. We're talking about orders of magnitude difference. The fact that an MSTP network is slow doesn't necessarily mean that it is the root cause. The root cause can come from outside. So let me ask you first, if you do have an MSTP network that is not performing well, if you disconnect it from other networks, does it continue to perform poorly? If it does, then it's likely the problem is local to the MSTP network, and it's actually very likely that the problem is physical. If you don't want to isolate, but you want to see if the problem is physical, you could use a MSTP capture. Check out the link here. It will take you to a page on optigonetworks with lots of resources. If you do a capture and you see checksum errors, checksum error means that the packet is likely corrupted, or you see a lot of what we call poll from master and reply to poll from master, it likely means a token is lost. Of course, if you have access to Visual BACnet or Optigo Visual Networks, use that, put that in. It will tell you if there's checksum errors, lost tokens, a token disruption, and using that, you can infer the problem is likely physical. When a MSTP network is connected to other networks, the network can also often be slow because of external effects. The greater system, the greater BACnet internetwork has a lot of traffic, has a lot of broadcast traffic. Those broadcast packets will also be forwarded back into the MSTP network and causing the MSTP network to choke. Of course, if you have access to Optigo Visual Networks, take a look at that. Look at if there's a lot of broadcast traffic coming in and what's the source of the broadcast traffic. If the source is external to the MSTP network, that's a good hint that the problems are coming from outside. Fairly simple, fairly easy. You may already have a device that's capable of BACnet routing, enable routing connected to the IP network, and voila, you are done. If you do not have a BACnet router or a device capable of routing BACnet traffic, add a BACnet router. There are quite a few out there, and that allows you to interconnect a modern IT network to an MSTP network. We are doing this series of short videos to answer any questions you may have. If you have questions around BACnet systems, how BACnet works on OT networks, how IT and OT works in combination, send in your questions and we'll get to it. Thank you.